Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on mathematics grade 11 functions, particularly focusing on the parabola and the straight line. And this question number 6, comes from the November 2019 paper of the Department of Education. Let's start. The diagram below shows the graphs of f of x equals to minus x squared plus 2x plus 15 and g of x equals to minus 3x plus k. F of x is the parabola, you can even see with the equation, and g of x is the equation of the straight line. Graph f cuts the x-axis at point A, negative 3, 0, which is the x-intercept of the parabola, and B, 5, 0, which is the other x-intercept of the parabola. The y-axis at C, so the parabola cuts the y-axis at point C and has a turning point at point D. Graph G cuts the x-axis at B, that is the straight line, and the y-axis at C. So graph G and F have got a common x-intercept at B and also share a common y-intercept at C. E is a point on G, the straight line, such that DE is parallel to the y-axis. Question 6.1 show that k equals to 15, and this is only one mark. Notice that k is part of the equation of the straight line. So what you do is you take the point that lies on the straight line that has got the coordinates given to us, which is point B, and you substitute that into the equation of the straight line so you can find the missing value, which is k. So that's what we do. 6.1. First, write the equation of the straight line, which is minus 3x plus k. Then we go point B, where the coordinates 5, 0, lies on G. It lies on G, therefore we substitute. Let's substitute. Wherever there is x, you substitute the x coordinate of the point, and wherever there is y, you substitute the y coordinate. So 0 equals to negative 3 in bracket 5 plus k. That is minus 15 plus k. Now take everything that is not k to the left hand side, so we make k the subject of the formula, and this is what we have as an answer. That is the value of k. We've shown it. Now 6.2 goes, determine the coordinates of D, which is the turning point of F. Remember, F is the parabola, and here is the equation of that parabola. We've got two types of standard formats of the parabola. This is the first one that you learn in grade 9, and the second one is the one that you learn in grade 11. Now, whenever you have this old standard format of the parabola, to find the turning point for this one, you use the ABC type of scenario that we've learned in grade 9 that we use in grade 11 to find and make the quadratic formula. So that is minus x squared plus, let's go back, plus 2x plus 15 plus 2x plus 15. So now from this, we're looking for the turning point, right? That's our question mark. From this, let's figure out what our A is, what our B is, and what our C is. A is the coefficient of x squared, so that will be negative 1, and B is the coefficient of x, which is 2. C is the constant, which is 15. Now, the equation of the x-intercept, the x-coordinate of the turning point, whenever you have this standard format, is minus b over 2a. Now let's substitute. That will be minus 2 over 2 times negative 1, which gives us 2 over 2, which is equals to 1. That's the x-coordinate of that turning point. Now to find the y-coordinate, you substitute this one back into the equation of the parabola. That will give you the y coordinate. And that gives us minus 1 plus 2 plus 15. That is 17 minus 1, and that gives us 16. Therefore, the turning point has got the coordinates. The turning point has got the coordinates 1, 16. Meaning that the coordinates of D, let's go back to the question. Determine the coordinates of D, the turning point. Therefore, the coordinates of D are, therefore, dxy has got the coordinates 1, 16. Now 6.3. Goes, determine the values of x for which f is increasing. Now, in order to determine whether a function is increasing or decreasing, you start from the left and go all the way to the right. So you take your finger, put it on the left hand side of the whole system, and then look at the function that you are trying to figure out the behavior of as you go to the right. So here is the function that we're looking at, f of x. Now on the left, from the left all the way to the right, it increases until you get to the turning point, which has got the coordinates 116. Very important to have those coordinates there, because they're going to give us the clue as to what the x coordinate at that point is. Now the x coordinate on the x-axis is 1 and the y coordinate is 0. Now, according to the shape of the graph, as we go from left to right, there you get to the turning point at D, and until it gets to the turning point, it is increasing. But to the right of that, in other words, after this point, it decreases. So what is the important x coordinate at that point? That is x equals to 1. So until it gets to 1, from the left all the way to x equals to 1, it is increasing. Therefore, the answer is f is increasing for x is less than 1. We do not include 1 because at 1, that's where it is not increasing and not decreasing, because that is the turning point. So the answer to this question is x is less than 1, because to the left of 1, that's when it increases. 6.4. Calculate the average gradient between points A and D. We know the coordinates of A and D. To find the gradient, that's very easy. You use the equation of the gradient of a straight line that we've already, like by now you should know. The equation of the gradient of the straight line. Okay, we've got point A. Here are the coordinates of A, and then D has got the coordinates 116. 116. Let's go back to point A. I think it's negative 30. Okay, let's go. These are the coordinates, negative 30. Let's fix that, negative 30. Now the equation of the gradient of a straight line is very easy. That is MAD, that is equals to y2 minus y1 over x2 minus x1, which gives us what? Now y2, you can choose whichever you want to be, y2, y1, it does not matter, but make sure that you stick to that order of the choice that you make. So I'm going to make my x2 y2d and my x1 y1 a. So that will be equals to y2 will be 16 according to my choice, and then y1 will be 0 over x2 will be 1. Notice, don't switch them around or your gradient is going to be wrong. That is equals to 16 over 1 plus 3, which gives us equals to 16 over 4. And 16 over 4 is equals to 4. And that is the gradient of AD. Question number 6.5. Calculate the length of DE. Now, when it comes to DE, to find the length, because obviously we're going from top to bottom, to find the length we need to know the y coordinate of this point at E. Now point E lies on the straight line with the equation g of x equals to minus 3x plus 15, like we already shown it there. So what we need to do is to figure out what the y-intercept is over there. So that is 6.5. Let's find the y-intercept of the coordinate of E. E has got the coordinates 1, y we already know, but we don't know what the rest of the coordinates are. So let's find them out. That's what we have. We need to know what the y coordinate is. Now in order to find the y coordinate, because that point lies on G, the straight line, we need to find the G of 1, meaning that we substitute. That is equals to minus 3 plus 15, and that gives us 15 minus 3, that gives us 12. Therefore the y coordinate of that point is 12. And in order to find the distance, let's go back. So the y coordinate is 12, so this is 1, 12. Now DE is simply 16 minus 12. DE is simply 16 minus 12, and 16 minus 12 gives us 4 units. And that is the answer. So DE equals to 16 minus 12, which is equals to 4 units. Next, question 6.6. If h of x equals to f of x minus 1 minus 2, determine the equation of h in the form h of x equals to a in bracket x plus p all squared plus q. Remember we talked about two types of standard formats, the one that we're currently busy with and this one. This is the second standard format of the equation of a parabola, and to find this you will see exactly what we do. We need to complete the square, but first let's substitute x minus 1 wherever there is x. First of all, here is what we are told. Let's go to the next page, 6.6. Remember h of x equals to, h of x equals to f of x equals to minus x squared plus 2x plus 15. That's what it is. Now we are told that h of x is equals to f of x minus 1, and then the rest of the question goes minus 1 minus 2 minus 2. So how do we work this one out? It looks difficult, but it's actually very easy. So basically wherever on f of x, wherever there is x, you substitute that with x minus 1. So minus x squared will be minus x in bracket x minus 1 all squared. So wherever there is x, you put x minus 1. That's how you substitute that. Minus 2. Sorry, that is plus 15. Don't forget the plus 15, and then minus 2. Plus 15 and then minus 2. This is your f of x minus 1, and then the minus 2 side. You gotta be careful when you substitute, because that's where you can make a lot of mistakes. Now let's expand this. Okay, in order to expand this, this will be minus x. We are squaring a binomial. Remember, when you square a binomial, that will be the square of the first term plus 2 times the product of the two terms with their signs minus plus the square of the last term. That's exactly what we do. So we go x all squared plus minus x all squared, sorry, let's fix that. So it should be minus in bracket x all squared plus 2 in bracket x times minus 1 plus negative 1 all squared, and then you list the rest of the, so that will be plus 2x minus 2 plus 15 and then minus 2. That is equals to, all right, minus x squared. Okay, let me fix that. It's not necessary. Okay, let's remove this. Okay, so that we can make sure that the whole thing is, okay, there we go. You must have a minus outside of that. Okay, now that gives us minus in bracket x squared minus 2x plus 1 plus 2x 15 minus 4. 15 minus 4 gives us 11, right, which is equals to, now let's take off the bracket so that we can factor in the negative sign, plus 2x plus 11. So we've got 2x plus 2x. Let's add like terms. That gives us minus x squared plus 4x. Then we've got minus 1 plus 11. That gives us 10. So that is plus 10. Now we complete the square so that we can convert this into the second standard format. So how do we complete the square? First we take out a negative, anything that will impact on the coefficient of x squared, so we take that out. All right, so taking out a minus leaves us with this scenario. Now we can complete the square of this, so that is minus 4x plus half times the coefficient of x squared minus the same thing, half times the coefficient of x all squared minus 10. All right, that is equals to minus in bracket x squared minus 4x. Now half of negative 4, half of negative 4 all squared is equals to negative 2 all squared, which is equals to 4. Now that gives us 4. So that will be plus 4 minus 4. Remember, when you complete the square, you must add and subtract so that ultimately you change nothing. So that's the goal. We do not want to change the formula. We just want to change how it looks. And now this is the square of a binomial, and the binomial is x minus 2. You can say times x minus 2. And then now you add minus 4 to minus 10. That gives us minus 14. Now I did this because I don't want to cut a corner, so you can follow. That is written as x minus 2 all squared minus 14. And now let's take off the bracket, and that leaves us with, and there your a is negative 1, and then you've got those, all those, right? There is the format that they were looking for. Now next question, let's remove this first. Next question is question 6.7. Let's go to 6.7. Determine the maximum value of p of x equals to 3 to the power of f of x minus 1. What is the maximum value of 3 to the power of f of x? Okay, this p of x equals to 3 to the power of f of x minus 12. That's what is the maximum value? Maximum value. This is maximum when the exponent, this whole p of x, which is 3 to the power of, is maximum at the point where f of x minus 12 is maximum. Is maximum. Remember, f of x is a parabola, so f of x minus 12, okay, let's go. F of x minus 12 is equal to minus x squared plus 2x plus 15 minus 12. And that is equals to what? Minus x squared plus 2x plus 3. 15 minus 12 is 3. Now, when is this function maximum? This is a parabola. Notice your a is negative, meaning that your arms will look down, meaning that therefore it will have the turning point is the maximum point. Now let's find what the turning point is. Now it's the same old standard format. So the turning point, the x coordinate of that turning point will be what? Minus b over 2a, which is minus, okay, what is our b over here? That is 2 over 2 negative 1, which is equals to negative 2 over negative 2, which is 1. All right, now let's substitute this back into this scenario. So let's call this a of x. All right, let's substitute that one into a of x to find the y coordinate of that turning point. A of 1 is equals to negative 1 all squared plus 2 times 1, negative 1 all squared plus 2 times 1 plus 3. And that is equals to minus 1 plus 2 plus 3, minus 1 plus 2 plus 3. So that is 5 minus 1, and that gives us 4. Therefore, it means that p of x, which is equals to 3 to the power of f of x minus 12, is maximum at 3 to the power of 4, which happens to be, take out your calculator if you're not sure, 3 to the power of 4, that is 81. So the maximum point is at 81. Now the last question, which is 6.8, says determine the values of x for which f of x plus k equals to 0 will have distinct real roots. F of x plus k. Remember k was supposed to be, we did solve that one out. So f of x plus k will have distinct real roots when will that be? All right, f of x plus k will have distinct roots if your delta is greater than 0. When it is equals to 0, you have equal roots. So let's go 6.8. F of x plus k will have unequal roots, which is distinct roots when our delta is greater than 0. All right, first of all, we need to figure out what f of x plus k is. So f of x plus k is equals to minus x squared plus 2x plus 15 plus k. All right, this makes our a equals to, remember, delta equals to b squared minus 4ac. Now our a in this case is equals to -1. Our b equals to 2 because that's the coefficient of x. And our c will be the whole 15 plus k. That is our c, 15 plus k. Delta will be, which is equals to b squared minus 4ac, which is equals to, will be greater than 0. Therefore, b is 2, so that will be 2 squared minus 4. A is -1 and c is 15 plus k. This will be greater than 0. Let's see, that's 4 plus 4 in bracket 15 plus k, greater than 0. Let's solve this inequality. Therefore, 4 plus 15 times 4, that is 60, plus 4k. This will be greater than 0 when 64 plus 4k. All right, so now let's take everything that is not k to the right hand side. That is -64. Therefore, divide both sides by 4. That will be -64 over 4. -64 over 4. That is equals to 16. -16. Therefore, f of x plus k equals to 0 will have distinct roots. Will have distinct roots when k is greater than -4. I mean -16. When k is greater than -16. And that is how you answer questions on the parabola. We've come to the end of this video. Thank you so much for watching. See you on the next one. Bye-bye.